Hello Antimatrix. In this video, I'm going to be going over Section A of your June examination. Mr. Borkin has already done Section B, so the link is available for you to go through that. Question 1A, number 1, 5 times 2 to the power of x is equal to 80. Now, in any exponential equation, remember that the aim is to make the bases on both sides the same. But firstly here, with the 5, there is a problem. So we're going to divide both sides by 5, so that we end up with 2 to the power of x is equal to 16. Right, and now you must show this step. Some of you didn't, where you make the bases the same. So you're going to reduce the right-hand side to 2 to the power of 4. And you can then equate the exponents, and therefore x equals 4. For number 2, x squared is less than 9. For any quadratic equation or inequality, you're going to first take over the 9 so that we have 0 on the right-hand side of the inequality. You can then factorize the left-hand side. That's a difference of 2 squares. So it becomes x minus 3, x plus 3 is less than 0. And that means that we have critical values at x equals 3 and x equals negative 3. Okay, so there are two different methods that you've been taught in order to do quadratic inequalities. Okay, so depending on the teacher, you might have been taught to use a parabola. So we can see that in this step, that parabola is a positive parabola because the coefficient of x squared is positive. So we can draw a positive parabola through our, let me make that a little bit more accurate. Okay, through our two critical values, which we mentioned were at negative 3 and at positive 3. And we then look at the parabola, and it tells us that the whole parabola needs to be less than 0. So in other words, we're looking for the negative solutions. So that means we want those solutions between. The other method that you may have been taught is to use testing values. So if we chose a value between negative 3 and 3, say for instance 0, and we substitute 0 into any equation where it's 0 on the one side. So 0 squared is 0 minus 9 gives us a negative answer. So that means between negative 3 and 3 they're positives. If we then choose something greater than positive 3, like let's say 10, and we substitute 10 in, 10 squared is 100 minus 9 gives us a positive answer, so there'll be a positive here. And then similarly on the left hand side, if you choose something less than negative 3, you also get a positive. And again, we're looking at this step. Any step where it's less than 0, well, this step particularly shows us that the parabola we wanted less than 0. So again, we're looking for the negative solutions. So again, we want these solutions. So our final solution for either of the two methods that you've used is that negative 3 is less than x, which is less than 3. And we don't use the inclusion, the less than or equal to, because this tells us that it can't be equal to 0. It can only be 0. Question B, solve for x and y simultaneously if they satisfy the following equations. Right, so we've got a linear equation and we've got another more complex equation. So always start with the linear equation, and you choose a variable in that equation that's going to be the most easiest to make the subject of the equation. So in this equation, I'd use y. I wouldn't use 2x, although you could and it would still work out, but if you use 2x, you have to end up dividing by 2, and then you're working with the fraction, which is not always ideal. All right, so if we make y the subject of the equation in the first equation, we end up with y is equal to 2x minus 7. Let's redo that. Okay, 2x minus 7. And label that equation 1. All right? And this can be equation 2. Now we're going to substitute equation 1 into equation 2. So in other words, wherever we see y in the original equation, in equation 2 at least, we're going to replace that y with our 2x minus 7. So in equation 2, we have x squared plus x times y, but y is now 2x minus 7, plus y squared, which is 2x minus 7 squared equals 7. And now you have to tidy this equation up. So we get x squared plus 2x squared, distributing the x, minus 7x, plus, and now we FOIL this bracket, so we get 4x squared. Then the outers, 2x times negative 7 is negative 14x. The inners will also be negative 14x, so that's negative 28x. And then negative 7 squared is positive 49, and that equals 7. Okay, so you can clearly see that it's still a quadratic equation, so we need to equate everything over the equal sign to 0 and also put it in standard form. So we start with the x squared terms. So x squared plus 2x squared is 3x squared, plus 4x squared is 7x squared. Then we can look at the x terms. So negative 7x minus 28x is negative 35x. And then lastly, look at the constants. All right, so our only constants are 49 and 7. But we're going to take the 7 over and subtract it from the 49 to get 42. So that'll be positive 42 on the left-hand side. And then we can divide through by 7. So x squared minus 5x, and then 42 divided by 7 gives us positive 6, and then now we factorize. Right, so this factorizes to x minus 3 into x minus 2. Therefore, x equals 3, or x equals 2. And now you've got to find out the corresponding y values for those two. So we look at any of the first equations that have y and x in, but the easiest one is this one that you substitute into equation 2, because you can do it in your head. Sorry, you don't need to show any working out for that. Okay, so for the first one, when x is equal to positive 3, substitute it into this. We get 2 times 3 is 6, minus 7 is negative 1. So y is equal to negative 1. And then similarly, when x is equal to 2, substitute it into the same equation. Equation 2 times 2 is 4, minus 7 is negative 3. So y is equal to negative 3. And that's your final answer. Question 2a, given g of x is equal to negative 2 to the power of x plus 4. So firstly, before you even answer the question, just understand what type of function it is. It's an exponential function, because you're going to have to end up drawing it in question 2. Right, so question 1 is determine the coordinates of the intercepts of G. So they're really just helping you work out the information that you need in order to sketch the function. All right, so firstly, for the y-intercept, it's not the same as a straight line graph where the constant is the y-intercept. So you need to substitute x equals 0. Okay, so you're going to make x equals 0 for the y-intercept. So we then end up with y equals minus 2 to the power of 0 plus 4. Now it's important to see that even in the original equation, that negative is not in a bracket with the 2. So it's not the negative that's being raised to the power of x, only the 2. So in other words, here it's almost as if we were going to put a bracket just around the 2 to the 0. And as you know, that's 1, but negative times 1 plus 4 gives us negative 3. So positive 3. So the y-intercept then is positive 3. And then for the x-intercept, we're going to let y equal 0. So 0 is equal to minus 2 to the power of x plus 4. And now we take the negative 2 to the x over, and it becomes positive 2 to the x. And the 4 we can reduce to 2 squared. Like I told you in the first question of the paper, we want to make the bases the same. And now we can equate the exponents so that x equals 2. Now they asked for the coordinates of the intercepts of G, so it's not good enough just to leave your answer like this. For the first one, you're going to say x is 0 and y is 3. And for the second one, we're going to say x is 2 and y is 0. Question 2, draw a neat sketch graph of G and clearly label any intercepts and asymptote or asymptotes that exist. All right, so firstly, we start with our information that we've worked out. We've already worked out that there's a y-intercept at positive 3 and there is an x-intercept at positive 2. You can estimate. That's why it's called a sketch. I still see people with rulers measuring 1 centimeter, 1 cent. You don't need to do that. Okay, estimate it. Make an educated estimate as to where those points should be. And then at positive 4, we have our vertical asymptote at y equals 4, because that's the constant in the equation. All right, so the constant in a exponential function that's in its standard form is always the equation of the horizontal asymptote. And then it's just a case of you joining the points up. So start very close to the asymptote on the left-hand side. You're going to go through your y-intercept, through your x-intercept, and then down. Always important to label your function. So this is the function of g of x is equal to negative 2 to the power of x plus 4. For number B, in the diagram above, the function f passes through the points negative 1, 5 and 6, negative 2. Determine the equation of f. Right, so if we start with the equation in standard form, y equals mx plus c, because it's a straight line, we need to work out what the y-intercept is. They haven't given us the y-intercept, but they have given us 2 coordinates. So we're going to use this coordinate and determine the gradient from those coordinates. So the gradient, remember, is y2 minus y1 over x2 minus x1. Substitute your values in. So if we make this coordinate 2 and this coordinate 1, then our y values at the top are going to be negative 2 minus 5, and at the bottom we're going to have 6 minus negative 1, which becomes 6 plus 1. Right, so that's negative 7 over 7, which is negative 1. Right, so we now substitute this coordinate, sorry, not that coordinate, we're going to substitute the gradient and one of the coordinates. It doesn't matter which one, so that we can solve for C. It doesn't matter which one. Okay, so let's substitute the second coordinate. So that means the y value is negative 2, and the gradient is negative 1, but the x value at that coordinate is 6, plus c. So we have minus 2 minus 6. If we take the 6 over, it becomes positive 6 minus 2, which is 4. So that means the c value in this equation is 4. So all we now need to do is to substitute our values back in. So therefore the equation of the straight line is f of x, because remember they've called it f, is equal to negative x plus 4. Question C. The function h illustrated above passes through the point 3 and 7 and has asymptotes of x equals 2 and y equals 4. So we know immediately that the x value there is 2 and the y value there is 4. Okay, so the standard form of the equation of a hyperbola, and they don't tell you it's a hyperbola, you must recognize by the shape that it's a hyperbola, is y is equal to a over, and now we've got the vertical asymptote is at x equals 2, so our denominator will be x minus 2. All right, we've got a horizontal asymptote at 4, so our constant will be positive 4. So now all we need to do is solve for a, and we do that by substituting in the point 3 and 7, which they've given to us. Right, so if we substitute 3 and 7 in, we get 7 is equal to a over 3 minus 2 plus 4. So 3 minus 2 is 1. So all we need to do is take over the 4, and we get 3 is equal to a. So that means the equation of h of x is equal to 3 over x minus 2 plus 4. Question 2, write down the range of h. So the range of any hyperbola, unless they've given you a specific restriction, is that y is an element of all real numbers, but you need to exclude the value at which the asymptote lies. Okay, so y cannot equal positive 4. Is h an increasing or decreasing function? Let's look quickly at the diagram again. It's decreasing because from left to right, our graph is going downhill. And then at the top here, it starts again and goes downhill. Right, so unlike a parabola, a hyperbola will only increase or it'll only decrease. It won't decrease and increase in the same function. Right, so this one is a decreasing function. Question 4. H is reflected about the x-axis to form graph P. Determine the equation of P. Okay, so let's just remind ourselves, equation H is y is equal to 3 over x minus 2 plus 4. Now, if we're reflecting on the x-axis, the y value changes its sign. So therefore, graph P will be negative y is equal to 3 over x minus 2 plus 4. But we want the graph in terms of P of x, so we need to divide everything by negative. So then the negative y becomes positive y, which is P of x, and negative 3 over x minus 2 minus 4. And that'll be the equation of the reflection. Question 5. H is reflected about the y-axis to form graph T. Write down the equations of the asymptotes of T. Okay, so if we go back to the diagram, if it's reflected about the y-axis, then that means this side is reflecting to that side, and the y-axis is the mirror. So in other words, this asymptote will reflect to negative 2. But the horizontal asymptote will stay the same because we're reflecting left to right. Okay, so there's no up-down movement. There's effectively only left to right movement. All right, so the equation then of the asymptotes, x is negative 2, because that does reflect over the y-axis, but y is still equal to 4. That doesn't change. Question 3a. On the Cartesian plane above, root 3 and negative 1 and a and negative 4 are points on the terminal arm formed by angle theta. By using the diagram above and without the use of a calculator, evaluate 1a. Alright, so if you look at the relationship between the y values, the negative 1 is being multiplied by 4 to get to negative 4. So therefore the root 3 times 4 will give us a. So root 3 times 4 is 4 root 3. Alright, so a equals 4 root 3. Alright, question 2, tan 180 plus theta. So tan 180 plus theta is in quadrant 3. And in quadrant 3, tan is negative. So this actually becomes negative tan of theta. And then using our coordinates that we have, it'll be negative times, and then tan theta is y over x, so it's negative 1 over root 3, and that equals 1 over root 3. You must not use the calculator, so it's important that you show this step. And if you've got an answer that says root 3 over 3, we'll know you've used the calculator because you were supposed to use these coordinates that were given to you. So be careful. And then for question 3, the magnitude of theta, the size of theta. Here you use your special angles as well as symmetry on your graph to get the fact that theta is equal to 330 degrees. Okay, question B, simplify fully. Alright, so we've got some reduction to do here. Cos of 90 minus theta becomes sine of theta times cos 20, and the cos 20 is not an obtuse angle, it's an acute angle, so we leave it like that. But if you look at the sine 70 at the bottom, we know that sine 70 is the complement of cos 20, so we can replace the sine 70 at the bottom with cos 20, because then we know that those two cos 20s are going to actually cancel out. Okay, and then tan of negative theta, using your negative angle rules, is negative tan theta. Okay, so it's a good idea here to see that this is all one term. So we know our answer is going to be negative. Now we've already dealt with that negative. And sine theta over tan theta. So tan theta is sine theta over cos theta. And now you can tip and times so that you have sine theta times cos theta over sine theta. Okay, so we've just tipped and times that denominator. The signs now cancel, and your answer then is negative cos theta. Okay, question C. Given that sine 32 is equal to t, express the following in terms of t showing all your working. So the important thing here is that you first have to show that these can be reduced using reduction formulae. Okay, so 238 is in quadrant 3, so we would use the 180 plus. So 180 degrees plus 58 degrees is equal to 238. And now, because it's in quadrant 3, cos is negative there, so this will become negative cos 58 degrees. And 58 and 32 add up to 90, so we can use complementary angles here to make that sine of 32 degrees. Okay, so therefore this is negative t, because sine 32 is equal to t. Okay, question 2, sine of negative 148. Firstly, use your negative angle rules to make the sine of negative sine of positive 148, and then you're going to use reduction. All right, so this is in quadrant 2, so this becomes negative sine 180 minus 32 degrees. All right, and then that sine 180 minus 32 is in quadrant 2 where sine's positive, but because of the negative at the beginning, it'll become negative sine 32 degrees, and so this answer is also negative t. Question D, prove the following identity. So we've got tan squared over 1 plus tan squared on the left equals sine squared on the right. Okay, so we're going to work with the left-hand side. And remember, when you see tans, you're going to change them into sines over cos. Okay, so the left-hand side, the numerator, is sine squared x over cos squared x, and that's divided by 1 plus sine squared x over cos squared x. Okay, so in the next step, we're going to get an LCD at the bottom in that bracket. Alright, so in the bracket, denominator of cos squared x, so then the 1 then becomes cos squared x plus sine squared x. Alright, and so now we can do two things. We can tip and times, so that we have sine squared x over cos squared x, change the divider to a multiply sign, then the cos squared that was at the bottom goes to the top, and at the top the cos squared x plus sine squared x is equal to 1. Alright, so the cos squared x is cancel, and then we're left with just sine squared x, and that's equal to your right hand side. Question E, simplify. So we have two expressions here. At the top we've got a trinomial, and that factorizes to 2 sine theta minus cos theta into sine theta plus cos theta. And the bottom is a difference of two squares. So we have 2 sine theta minus cos theta, and then you almost always are going to cancel one of the brackets or something at the top. So if you're stuck with how to factorize, then if you've already factorized either the numerator or the denominator, then normally one of those factors are going to be in the other one. Okay, so 2 sine theta minus cos theta and 2 sine theta plus cos theta. Okay, so these cancel, and you end up with sine theta plus cos theta over 2 sine theta plus cos theta. Okay, can't do anything further there. I saw some people in the exam try to factorize a 2 out, so you can cancel the sine theta plus cos theta, but you can't do that. Question 4 is the proof, so I'm not going to do that on this video. You can consult the memo and your textbook for that proof. It's just complete and straight learning work. Question 5. In the diagram above, O is the center of the circle and angle Q2 is 40 degrees. Determine with reasons the magnitude of each of the following. So number 1, Q1. So they're wanting the size of that one. Alright, so this one's fairly easy and you should have lots of colors and marking on your diagram, but we know that that is 90 degrees because O is the center of the circle. Okay, so that's our starting point, where we say that angle PQR is equal to 90 degrees, and the reason is angles in semicircle. And then that means that Q1 is equal to 90 degrees minus 40 degrees, because they've given that Q2 is equal to 40 degrees, so therefore Q1 is equal to 50 degrees. Question 201. Now if we have a look at the diagram, O1 is over here, and we've now worked out, and you should be writing in your diagram when you've worked out what things are, we know that this is now 50 degrees, which means that O1 is 100 degrees because of our angle at center reason. Alright, so O1, no working out here, is equal to 100 degrees, and the reason is angle at center is equal to twice the angle at circle. Question 3S2. So if we have a look and let's plan here, they're wanting us to work out this angle. Okay, so the first thing we know is that OP and OS are equal, all right, because they are radii. So if those are equal, then it means that S2 and P2 are also equal. And using angles in this triangle, we know that we can subtract 100 from 180, which is O1, and therefore that'll give us the sum of P2 and S2, and we can then divide by 2 to give us this value of S2 because they're equal. Alright, so let's look at how we set that out. So firstly, we need to state that OP is equal to OS, and that's because they are radii. So we're just basically establishing that it's an isosceles triangle. And then our next step is that P2 is equal to S2. P2 equals S2, and that is equal to 180 minus 100 degrees divided by 2. Alright, and that's because of isosceles triangle POS. Alright, so therefore S2 is equal to 180 minus 100 is 80, divided by 2 is 40 degrees. Question B, in the diagram below, the two circles intersect at C and E. So they've shown us that. There's C and there's E. G is a point on chord HF in the bigger circle. They're telling you it's a chord as well, so that you know it's a straight line. GE is a tangent to the smaller circle at E, so there's the point of tangency. And GHC is equal to 75 degrees. D is a point on the smaller circle with CDE equal to 73 degrees. Okay, giving reasons where required, determine the size of E1. So they want this one. Okay, so our starting point is to see that angle E2 is equal to 73 degrees. Okay, so let's mark them. And that's because GE is given as a tangent, and then here we see the triangle in the smaller circle. So the outside angle is equal to the angle made by or subtended by the chord in the alternate segment. Okay, so E2 is equal to 73 degrees. We're going to write it all down in a minute. We're just planning at the moment. Okay, so secondly, we know that the sum of these two angles, E1 plus E2, must add to 180 to give us 75, okay? And that's because HFEC is a cyclic quad. All right, so that's basically our equation that we're going to work out. So we basically need to say, remember we're solving for E1. So E1 plus E2 plus 75 equals 180 degrees. All right, so let's put it all together. Try and fit everything on. Okay. So, our starting point, as we said, is that E2 was equal to 73 degrees, and the reason is tan chord theorem. And then secondly, angle E1, which is the angle we're looking for, plus angle E2, plus angle H must be equal to 180 degrees, and that's opposite angles of cyclic quad. And then we substitute in accordingly. So angle E1 is what we're looking for. Angle E2 we've worked out as 73 degrees. Angle H is given as 75 degrees. And then all we need to do is take everything over and solve for E1. So E1 therefore is equal to 32 degrees. And that is the end of section A.